Hello, I have another question from 6.3 exponential functions. This is actually a matching kind of a type of problems. And 29 to 36, 29 to 36 gives you just basically different graphs. And 31 and 35 I got demonstrated here. So this would be the graph of 31 that's in the book and 35 in the book. Okay. Uh, these are the choices: A, B, C, D, E, F, G, and H. So one of these functions is associated with this graph, and another one of these functions is associated with number 35. And remember now, when you're doing matching, you got to be smart about this thing. You don't want to reinvent the wheel every time. So in other words, when you find the matching for number 31, it's eliminated from contention for any of the other graphs. So same thing with 35. So as the problems get you progressively go into them, it should get easier because you have less choices. So 31, we're going to figure out what the match is with 31. So now 31 is an upside down exponential function. Actually, it levels off to the positive side and it runs off to negative infinity. But here's the key, okay? When you're just doing matching, one good thing is to figure out one of the points that they have. In this case, 0, -1. So what you would do is you would go through and put 0 in every one of these. And it's going to eliminate quite a few of them. Not all of them. If it eliminates every one except for one, then that's good because we got that one that remains is done. So it'll probably be a little easy. I don't know if it's going to do that or not. So let's put 0 in. Okay, if we put 0 in here, we get 3 to the 0, which is 1. Well, that's not it. So A is not number 31. So if you put 0 into this one, 3 to the -0 is still 3 to the 0, which is also 1. So that's not it either. So we put 0 into this one. So 0, okay. Now, this is where a lot of people get confused. It's not -3 to the 0. It's actually 3 to the 0. Take the opposite because it's the order of operations. So it'd be 3 to the 0, which is 1, and then take the opposite of that, which is -1. The only way you'd have a -3 to the 0 is if -3 was in parentheses. But in that case, it would not even be an exponential function because remember, bases have to be greater than 0 and not equal to 1. So if you put -3 in parentheses, it would be a function, but it would not be an exponential function, so it wouldn't even be into this section. So whenever you have a negative in the front, it's applied later, not at the beginning, because of the order of operations. 3 to the 0, so 0, -1. And that is a possibility. So C is a possibility. So what I'm going to do is I'm going to put a little asterisk by that one to remind myself that that is a possibility. And we'll do the next one, this one. 0. 3 to the -0 is still 3 to the 0, which is 1. So it's a -1. So that's also a possibility. C and D. Now let's try E. If I put 0 in here, 3 to the 0, which is 1, and then 1 minus 1 is 0, so it goes to the origin, which cannot be 31 then, because this one definitely does not go to the origin. If I put 0 into this one, 0 minus 1 is -1, and that'd be 3 to the -1, which is 1/3. So that's not it either. Put 0 into this one. 1 minus 0 is 1. 3 to the 1 is 3. That's not it. So it's looking like C and D are the two possibles. Let's try this one just to make sure. 0. 3 to the 0 is 1. And then 1 minus that 1 is 0. So the choices that I have is actually C or D for 31. Okay. So which one is it? Well, yeah, you could do another point. Okay. You could put in, let's say, 1. And if you put 1 in, and if it's somewhere between, whichever is between those closest, you could technically now at this point go ahead and graph these two, and whichever one is that one. You could do a little T-chart like we've done before in class. You could do a T-chart. But since it's a match, I wouldn't know if I would go all the way through the whole procedure to in the whole graph, because you're just doing matching anyway. So you might want to do one more point, okay, on both of these. Just these two, because we got to narrow down these two though. So if we plug in 1, okay, be 3 to the 1, which is 3, so it's a -3. So the order pair should be at 1 minus 3, which should be down here. So C is probably not going to be it then. Okay, because if I put 1 in, I get -3, which just should be down here. The graph is up here between -1 and 0. So it'll look like D probably is the answer. So let's make sure. So we put 1 in for this one. Okay, 3 to the -1, which is 1/3, and the opposite of 1/3 is -1/3. And that looks reasonable because 1 down 1/3 is about right there. So D is the one that goes with 31. Now remember, since D is associated with 31, in other words, the graph of that function D goes together, then that D is eliminated from contention with all the other problems. So when I do 35 in a second, I'm not even going to do D. Okay, so that one's out of the mix. So 31 is D. So now 35, since I've already got some of the order pairs, I don't want to reinvent the wheel. So looks like this graph goes through the origin. So anything, when I put 0 in, I should get 0. So that wasn't it. That wasn't it. That one wasn't it. That could be this one. So it could be E. It could be H. It could be E or H. And again, just like I did on the C and D, do one more point. Or if you look at this very closely, there is a horizontal asymptote on 35 at -1. And that was a vertical shift downward. If you look at the E and H, which one has a vertical shift downward? Looks like it's looks like it's E because of the -1. Okay, but if you're not comfortable with that, you can do like we did in C or D, just find that second point. And so if we do that second point, let's plug in 1, and only between E and H. So we plug in 1. 3 to the 1 is 3, minus 1 is 2, so it's 1, 2. And looks like that might be close. 1 up 2 should be close. If we put 1 in this one, okay, 3 to the 1 is 3. 1 minus 3 is -2. 1, -2. So if the answer is H, that graph should be going through 1, -2, and definitely does not, because 1 is positive when you put 1 in. So H is not it. And you remember you already had narrowed down E and H already, and just because it goes to the origin. So E looks like the answer for number 35. So when you're doing the remaining 29 to 36, okay, remember E and D are out of contention because you've already taken D and put with 31, E you put with 35. So when you're doing the rest of them, the answer is going to be either A, B, C, F, G, or H. Okay, so that's how these are working. Some people don't do it that way. Some people will just go through and just graph A, graph B, graph C. In other words, do it backwards. Graph this A, and then we'll see which one it's assigned with. Problem with that is sometimes when problems are assigned, it's not all the problems you're doing. You may be doing just multiples of 3. So if you're not doing a multiple of 3 and you do it that way, then A might be associated with one that is not a multiple of 3. So you just basically did one for nothing. Not really for nothing, you're getting points for it. But the thing is, A, B, or C, do the graphs of those, see which one of the numbers it is. So you're just kind of going backwards. I like my way better. I like just doing about a couple of points and using 0 first. Okay, so if you do the 0 first, then you'll know which of the graph to kind of narrow it down to. And usually it narrows it down to a couple. So if you like this one, you're going to be looking at, there's like 2 graphs that have 0, 1, and 0, 1. Okay, and there's going to be 2 graphs that have 0, -1, and this one here was 0, -1. So if you can find one that goes through 0, 3, G looks like the only one that goes through 0, 3. That one's going to be an easier one. Okay, whatever's graph that's associated with G should be an easy one to identify because that'd be the only one that goes through 0, 3, because none of the other ones go through 0, 3. So anyway, that's it.